Hello everyone, welcome back to my geography lessons. Today's topic will be on anticyclones. So now, when we're talking about anticyclones, you remember from our first video, we said we can call them anticyclones or you can call them the high pressure systems. So these high pressure systems will influence the weather in South Africa during two seasons, and these seasons are indicated on this first slide. So we'll be looking at the weather in South Africa during summer, and we'll also be looking at the weather in South Africa during winter. So these are the two most important things. So you just need to know what happens during summer and also what happens during winter as a result of anticyclones. So before you can move to anticyclone, we need to know the characteristics of the high pressure system together with a low pressure system. So now, what happens in a high pressure system, the first and the most important thing is that you have this anti-clockwise rotation of air. So every time you see a high pressure, just know that the air rotates in an anti-clockwise direction in the southern hemisphere. But now when you go to the northern hemisphere, all your anticyclones on the high pressure system, they will have a clockwise direction. But for now, let's just know for southern hemisphere. Well, we are in the southern hemisphere. And then secondly, when we look at the low pressure system, we have this clockwise rotation of air. So these are the first and the most important differences between these two weather systems. A high pressure, it's anti-clockwise rotation, and then a low pressure with the clockwise rotation. And then secondly, when we look at a high pressure system, we are saying the air sinks in a high pressure system because this air is cold and it's heavy. Or you can use the term, we have a descending air. So you can see with our arrows that are going down, which indicates that we have a descending air. And then once the air descends or once the air sinks, the next process that will happen, the air will diverge at the surface in a high pressure system. So you know three characteristics now. Firstly, there's an anti-clockwise rotation of air. Secondly, the air sinks or descends in a high pressure, and then at the surface is diverging. When we talk about diverging, it's when the wind or the air move away from a high pressure. And then we go to a low pressure. The first thing that happens in a low pressure, the air or the wind converges at the surface. I hope you see the difference. When we talk about the high pressure, we say the air diverges at the surface, and then with the low pressure, the air converges at the surface. And then we have this thing which we learned about in grade 11, a pressure gradient force. So how does a pressure gradient force fit in this? We are saying this diverging air at the bottom or at the surface of a high pressure of an anticyclone. It's moved from a high pressure and then it goes towards your low pressure. And then what happens in a low pressure is converging. So what causes this wind to move from a high pressure here to a low pressure is something called a pressure gradient force. So do not forget about this. Air or wind will always move from a high pressure to a low pressure as a result of a pressure gradient force. Okay, and then after the air converges in a low pressure, the next process that will happen, your air is going to rise or it will ascend. The reason this air rises is because in a low pressure it is light. And then after it rises, what happens? It's going to form clouds. And then there's rainfall. So this happens only during summer in South Africa. And then during winter, we have this pressure, which is your Kalahari anticyclone, which we'll deal with on the next slide. And then another characteristic of these two is that in a low pressure, most of the time, we are going to have this weather station, the overcast weather station, and then this overcast condition, it tells you that there are clouds. And then these clouds, they will result in rainfall. And this only happens in a low pressure. So the conditions here, we are saying they are unstable because our wind, our air is light, it's able to converge, it's able to rise, it forms clouds, and then there will be rainfall. But looking on our high pressure, we are saying the conditions here, they are stable because of this cold sinking air, and then it diverges at the surface. Looking at the weather stations, during winter in South Africa, they will be like this, which means there will be clear weather conditions, which means there won't be cloud formation. Reason being is because this sinking air does not have capabilities to form clouds. And then what also happens is adiabatic warming of this descending air, which is also another characteristic of the high pressure, which means this descending air, it warms adiabatically. We'll also talk about that as we move forward. So please, the first and the most important thing, you need to know the characteristics of a high pressure and the characteristics of a low pressure system. Now let's move to the next diagram. Now let's deal with the winter conditions in South Africa. What happens during winter? So the first and the most important thing, you think about the anticyclone or your high pressure system. So what happens? Firstly, during winter in South Africa, we are going to have this high pressure system, which is called the South Atlantic high pressure. And why do we call it the South Atlantic high pressure? It's because it's found in the Atlantic Ocean. We know that's the ocean that is in the west of South Africa is called the Atlantic Ocean. So the high pressure that to be found here is the South Atlantic high pressure system. And then on the east of the country, we have Indian Ocean, which means the high pressure or the anticyclone that will be found on that ocean is a South Indian high pressure. Or you can just say a South Indian anticyclone. And then lastly, we have our Kalahari high pressure. So remember that there's the Kalahari desert right here in the interior around Northern Cape. So that's where this term, the Kalahari anticyclone and the Kalahari high pressure comes from that desert. I also told you this, that in geography we name things based on their location. Where are they from or where are they found? So in this case, we found the South Atlantic high pressure in the Atlantic Ocean. We find the Kalahari high pressure right in the interior only during winter. And then we find the South Indian high pressure in the Indian Ocean. So looking at the diagram or the synoptic weather map of South Africa, the most important thing is that all the high pressure systems are available. We find all the high pressure systems, which is the South Atlantic, the Kalahari, and the South Indian. And then let's look at their names. So firstly, we have this one, which is called the South Atlantic. Another term that they gave to this high pressure is the ST Helena high pressure. But you can just know the South Atlantic is fine. And then they say, during winter, what's happened is that the South Atlantic, it shifts north. Now, you remember from grade 11, that's all the weather system, they follow the ITCZ, which is your intertropical convergence zone. So during winter, the ITCZ has moved north because in this case, the northern hemisphere experiences summer. And then the southern hemisphere will experience winter, which causes all the weather systems to follow the direction of the ITCZ. So since the ITCZ is in the northern hemisphere, which means now all the weather systems they will shift northward. It doesn't mean they will go above the equator, just their position will shift northward. Which means now, if you see this South Atlantic high pressure, during summer it won't be located here. Instead, it should be around here. So now the reason it has shifted to this position northwards is because it follows the direction of the ITCZ. Okay, and then secondly we have the South Indian. Then the South Indian is also called the Mauritius high pressure cell or the Mauritius anticyclone. So similar to the South Atlantic, during winter, just like on this diagram, it's also shifted northward. And then the last one, we have the Kalahari high pressure, the Kalahari anticyclone. And then with the Kalahari, it doesn't shift northward or southward. What happens? They say it is situated over the plateau and it's well developed in winter. You remember that there's not direct heating. Or you can say the sun is weak during winter. So what's happened? There will be a Kalahari high pressure during winter, which means it's well developed. All the conditions of an anticyclone that we talk about, the sinking air, the cold air, and the diverging air, they will be experienced during a winter in the interior of South Africa. And then it says, but shift into the upper atmosphere in summer. So during summer, because of heating, we are not going to have it will move to the upper atmosphere. And then we're going to the low pressure in the interior only during summer. So how do you know the difference between summer and winter? It's that during winter, we have a well-developed Kalahari high pressure. And also during winter, our two anticyclones, the South Atlantic and the South Indian, they shifted north. But during summer, it's the opposite. During summer, the South Atlantic and the South Indian, they shift towards south. We are going to see the diagram. And then the next thing that happens during summer is that it's north of the Kalahari plate. We have a low pressure instead, which we'll also deal with. And then the next thing that happens during winter is that our weather station, when you look at the interior, you will see that we are experiencing clear skies. And why do you have clear skies? It's because of this Kalahari plate. We said one of the characteristics with the sinking or descending air. And once the air sinks, there will be no cloud formation. There will be cold condition. And then your weather systems, they will be clear, just like here. So most of the country experiences clear conditions. But it's only the west that experiences overcast condition. And why do we have overcast condition? It's because of the passing cold front. We said all the weather systems they shift northward. So even the mid-latitude cyclone or the cold front, it has shifted northward, causing this cold front to be able to reach the interior. Now, if you can look on this diagram, you can see that the cold front is touching this part of the Western Cape. It's touching Cape Town. And if we have a cold front touching a plate, you'll also remember from the mid-latitude cyclone that in a cold front we find the cumulonimbus clouds. So these cumulonimbus clouds are the one which causes overcast conditions, and there will be thunderstorms, there will be heavy rainfall only in the Western Cape. And what causes that is the passing mid-latitude cyclone or the passing cold front. But the rest of the country it experiences cold conditions and it also experiences clear skies. So you need to know this. In this slide you can see it's in colors and you can see it's more like a video, but it's just the GIS imaging. But in an exam you're not going to find something like this. You just need to know the characteristics of all these things. And then now let us shift to summer conditions. Now during summer conditions, you remember in winter, the first thing that we had our anticyclone right here at the top or in the north position. But during summer, both of these they shift southward. Let us compare. This is where you're going to find your South Atlantic high pressure during winter and the South Indian. But look at summer. It's no longer in this location, instead it has shifted south. And why did it shift south? It's because the ITCZ now is in the southern hemisphere. And once the ITCZ is in the southern hemisphere, which means all the weather system, they will shift southward. And also, this South Atlantic high pressure is also called a blocking high pressure. Why is it a blocking high pressure? It's because it has blocked a mid-latitude cyclone or the passing cold front from reaching the Western Cape. So now it's no longer able to reach the Western Cape. Firstly, it's because it has shifted southward, the mid-latitude cyclone and the cold front. And then secondly, it's because it is blocked by your South Atlantic high pressure. So all these conditions they persist over summer or over South Africa in summer. And then what do we have in the interior? We no longer have the Kalahari high pressure. Instead, there's something called a thermal low pressure. Or you can also call it a heat low pressure. So how did this heat low pressure develop? It has developed as a result of surface heating. It's summer. ITC has shifted south. And then, once it shifts south, which is now there will be a direct heating of land during summer, which causes a development of a thermal or a heat loop. And then, let us look at this. They are saying the first and the most important thing, there is no Kalahari or continental high pressure during summer. We only find the Kalahari during winter. So what happened with the Kalahari? It has shifted northward. And then the next thing that's happened, they are saying the thermal or heat flow is visible as a result of surface heating and high temperatures over the interior. You remember that if you have high temperatures, definitely you will have a low pressure developing there. So you are not going to have a cold air while you have a direct heating of the land. And then what's happened during this season? We have overcast conditions, especially on the eastern parts. And it is because of light thunderstorm and moisture front, which we'll deal with on our next video. So what happens here? The entire country experiences overcast conditions, even in the western parts, but not that much compared to on the eastern parts. Okay, so now let us look at the weather in detail. So what happened now? We are looking at the cross section. Already you know the diagram, or you know the snowstick weather map for summer, you know the snowstick weather map for winter. So now if you were to draw a cross section, most of the time a cross section will be on this side, the eastern side of the country. So now what's happened during winter? This is a cross section. So what do we have in this cross section? Firstly, we have our plateau. Right here, this is South Africa, we are only looking on one side, and then we have the escarpment right here, this is the escarpment, and then with the coastal areas, you can see there we have the ocean. So now, firstly, we are saying, the first and the most important thing which we already talked about is that during winter, the South Africa is dominated by the high pressure cells, which means all the three high pressure cells, South Atlantic, South Indian, and the Kalahari, they are visible. So that's what I'm telling you. It's dominated by the subtropical high pressure cell. And why do they say subtropical? It is because South Africa lies at 30 degrees. And you remember that as 30-degree line of latitude, we have what we call the subtropical high pressure. So all these three high pressure, they are results of the 30-degree line of latitude. And then secondly, we are saying we have clear, cool, dry conditions. They persist over the summer rainfall area, which means during summer, the interior parts will have rainfall. But since when it is winter, we do not have rainfall. And reason being is the Kalahari high pressure. So what's happening in the Kalahari high pressure? You have these conditions. Firstly, we have clear sky. Secondly, we have cool conditions. Why cool? Because it's cold. We do not have the direct heating. And then lastly, we have dry conditions. Why do we have dry conditions? It is because there are no cloud formation. There's no rainfall. So all these three are the characteristics of the Kalahari Plain. And this happens during season during winter. And then we move. They are saying the passing mid-latitude cyclone, they call it something called a frontal rainfall. And then this frontal rainfall, where does it occur? In the Western Cape. And then it results in rainfall, and then the type of climate, which is the Mediterranean area or climate. So this is where it is happening. So the reason you see this cold front, it is because of this passing mid-latitude cyclone. And then there will be frontal rainfall from this kilomanimbus south, resulting in overcast conditions, and then high rainfall. And we said during winter we only have rainfalls on the Western Cape, or in the Western Cape, on the western side of the country, as a result of a mid-latitude cyclone. But the whole country experiences cool, dry conditions. And then the next thing, the subsiding air in the Kalahari high pressure, then it keeps up as dry at the vertical rate and is warmer than the air from coastal areas. This is also the characteristic we talk about. We said in the interior, or when we have a high pressure, this subsiding air or the sinking air, it heats up as dry at the particular rate, which means as it sinks, it gains a temperature, and then it will be warmer than the surrounding area. But do not forget that this air is cold as it moves from the top going down. And then we also have something called an inversion form below the escarpment. There is our inversion there. So now what's happening in this diagram, in this cross section? It's winter. We have a subsiding air. This is the first thing you need to look at. We have this subsiding air. And where does this subsiding air come from? It's come from the Kalahari high pressure. So during this season, during winter, the Kalahari high pressure, it causes subsiding air. And then this subsiding air, it pushes this thing called a temperature inversion. It pushes the temperature inversion from the upper atmosphere, and then it makes it to be below the escarpment. And once the temperature inversion is below the escarpment, what will happen? This warm moist air from the ocean, it won't be able to reach the interior. Instead, it will be blocked by this temperature inversion, causing this warm moist air to revert back. Which means during this season, we are not going to have any warm air reaching the interior because of two reasons. Firstly, because of temperature inversion being below the escarpment, blocking this air. Secondly, because of this sinking air, blocking this warm moist air from reaching the interior. And then, this says when the inversion layer is below the escarpment, what will happen next is that the subsiding air also prevents any air from reaching the interior. Which I just explained now. Which means there will be no air that will be able to reach the interior of the country as a result of subsiding air and as a result of the temperature inversion acting as a blockage for this warm moist air. And then lastly, they're saying there will be no rain that occurs over the interior in winter. And why there will be no rain? It's because this warm moist air capable of forming rainfall. In this case, it's unable to reach the interior. So that is going to cause cool, clear, and dry conditions inside the country. So now you can see where do all these characteristics come from. It's clear because there won't be cloud, since when the warm moist air was blocked from entering the interior. And then it's cool as a result of this subsiding air. And it's also dry as a result of no cloud formation and no rainfall. And also as a result of this subsiding air, they pick up as dry at that particular place. As it sinks, it becomes drier and drier. And also warm. So all these conditions we experience them during winter. So now let's go during summer. What happens during summer? Okay, then the last thing before we move, they are saying the presence of the Kalahari is also called something called the back winds, which we talk about. I said when we begin during winter, the weather phenomenon that occurs are back winds. So the back winds, they occur as a result of the Kalahari high pressure and a coastal low pressure. In this case, we do not have our coastal low pressure, but we'll deal with back winds. So let's move to the next. During summer, you know that we have the South Atlantic anticyclone, with the South Indian anticyclone, and there is an anti-clockwise rotation of air. And then basically here in the interior, we have our clockwise rotation of air as a result of the thermal or the heat flow. And then the cross section for winter will be like. So before you can go to the note, what you need to know about this cross section, comparing it with winter. During summer, the temperature inversion is no longer below the escarpment. Instead, it's above the escarpment. So that is the most important thing. Comparing winter and summer, the cross section, you will see that during summer, temperature inversion is above the escarpment. During winter, it's below the escarpment. And if the temperature inversion is above the escarpment, what does that tell you? It tells you that the warm moist air from the ocean will be able to reach the interior. Just like on this diagram, you can see the arrow is reaching the interior. Reason is because temperature inversion has acted as a door now, which means it allows any warm moist air from reaching the interior. Okay, so now let's see. So the first thing, we are saying the subtropical high pressure belt moves south with the heat decrease, which means the ITCZ moves south. And then all the weather system, they will also move south. And which weather system? The South Atlantic, the South Indian, and the mid-latitude cyclone. That's why it's not visible during summer. It says move south. It's not going to affect South Africa in any way. And then secondly, the Kalahari high pressure is listed above the escarpment. That's why you do not say Kalahari high pressure in this diagram. Reason being, it has been lifted above the escarpment as a result of surface heating. And then the next thing, we have a low pressure which developed as a result of this surface heating and also high temperatures. And then the name of this low pressure we dealt with is the thermal low or a heat low. And then we are saying the warm moist air masses, they bring humid air over the interior, which causes the summer rain as the moisture front of the country. So before you can go to this point, when you explain the cross section, the first thing that you need to talk about is the temperature inversion. So we are going to say, as a result of the Kalahari high pressure being lifted above the escarpment, as a result of surface heating, this causes the temperature inversion to also be in the upper atmosphere, also be above the escarpment. So there are two things that are above the escarpment in this case. Firstly, you have the color high pressure being lifted above or in the upper atmosphere, and then secondly, we are going to have a temperature inversion being above the escarpment. And then once the temperature inversion is above the escarpment, then this point comes in. The warm moist air is able to reach the interior of the country. And then once it reaches the interior of the country, it's going to be cloud formation, we are going to rainfall. And also, you need to remember that here we have a south Indian high pressure, which means right now in the ocean we have high pressure, and then in the interior we have a thermal low. What is going to happen? It's a pressure gradient force, which means now the air or the wind will move from the high pressure in the ocean, and then it will move towards a low pressure in the interior. And what are the characteristics of a low pressure? Firstly, the air converges. After converging, it rises. After rising, it forms clouds. There will be heavy rainfalls. And then it's also evident on this diagram. So the reason you see all these weather stations being overcast, it's a result that the temperature inversion is above the escarpment, and also the warm moist air reaching the interior, it creates clouds, making this condition to be overcast, and then so these are the most important things that you need to know when we talk about summer and also winter conditions. Okay, so that's it for today, guys. You're going to catch my next video. We'll be talking about bare winds and also the moisture front.